So we had a differential equation, ds dt was 2 minus, right? So we had a differential equation that looked like this. So the first step would be to put this into standard form. So that would be the standard form for this differential equation. That would be our p of x that I have right there, right? So the p of x is the thing that is being multiplied to s. So our integrating factor is going to be e raised to the integral of p of x. So we're going to integrate 1 over 15 plus t and then exponentiate that. And again, at this stage, we can ignore the fact that there is more than one such function mu that's going to do this. We just want to find one, and let's pick the simplest one when c is 0, for example. So integrating 1 over 15 plus t would give us e to the natural log, technically, of the absolute value. But again, we just need to pick one such function that's going to work. So our integrating factor here, when I take e and raise it to the natural log, right, they undo each other, and I would just get 15 plus t. So this was kind of step 1. Write it in standard form. Step 2 was go ahead and find the integrating factor. And then the next step would be to multiply the differential equation that we have over here, both sides of it, by 15 plus t. And so when I multiply the left side by 15 plus t, just be sure you distribute it to both terms. So that's why we have a 1 in front of the s, because the 15 plus t divided by 15 plus t would cancel out. And now that left side, we can see, is what we would get if we were to take the derivative of the product of 15 plus t times s. Right? The product rule would say take derivative of s times 15 plus t, and then add the derivative of 15 plus t, which is 1 times s. Important here that every single thing in the equation gets multiplied by 15 plus t, or whatever that integrating factor is. And now we can integrate both sides with respect to t. The left side, those are going to undo each other. I'll come up here. So we would get 15 plus t times s is equal to 30t plus t squared. And now is a good time to include that arbitrary constant in our general solution.
We have to include it right now because when we divide the 15 plus t, it'll be the constant divided by t, which is dependent on something.
Exactly. Exactly, yes. So you don't want to just throw it in at the end. You want to throw it in after the stage of integrating the right side. That's right. And now when we solve for s, this gives us our general solution to the differential equation. Okay, that was exciting. We just solved our first integrating factor problem.